Ever wondered why carbon is so important in the world of chemistry? Well, that's because organic chemistry is all about studying carbon compounds. Carbon is a unique element. It has this unrivaled ability to bond strongly with other carbon atoms and atoms of different elements. And not just that, carbon atoms can form a large number of covalent bonds, 4 to be precise. Despite not being one of the most abundant elements on Earth, it's a crucial part of all living things. Yes, you heard it right. All living things are made up of organic compounds. Most organic chemicals are covalent compounds. You might find it curious, but compounds containing carbonate ions, bicarbonate ions, carbon dioxide, and carbon monoxide, despite having carbon, are not considered part of organic chemistry. So, carbon's unique properties make organic chemistry a fascinating field to explore. Now let's dive into the simplest organic compounds, hydrocarbons. Hydrocarbons, as the name suggests, are compounds composed exclusively of carbon and hydrogen atoms. They are the bedrock of organic chemistry, providing a foundation for understanding more complex structures. There are 2 main types of hydrocarbons that we need to focus on, alkanes and alkenes. These 2 types are distinguished by the kind of bonds that connect the carbon atoms in their structures. Let's start with alkanes. Alkanes are hydrocarbons with only single bonds between the carbon atoms. Think of them as a chain, which can be either a straight line or have branches. Each carbon atom in this chain is also bonded to hydrogen atoms. To make things easier, alkanes have a systematic naming system based on the number of carbon atoms in the molecule. The names consist of a stem that indicates the number of carbon atoms in the chain plus the ending -ane. For example, methane is an alkane with 1 carbon atom. The stem meth signifies 1 carbon atom. Similarly, ethane is an alkane with 2 carbon atoms, with eth indicating 2 carbon atoms. And the pattern continues. Propane is an alkane with 3 carbon atoms. Prop signifies 3 carbon atoms. Now let's shift gears to alkanes. Alkanes are hydrocarbons that have 1 or more carbon-carbon double bonds, denoted as C=C. Just like alkanes, alkenes also have a naming system. The names of alkenes have the same stem as the alkane with the same number of carbon atoms in its chain, but with the ending -ene. So, ethene is an alkene with 2 carbon atoms per molecule, and propane is a compound with 3 carbon atoms and 1 double bond. So there you have it. Alkanes and alkenes, the simplest hydrocarbons, are the building blocks of organic chemistry. While they may seem straightforward, their variations and combinations lead to the wonderful complexity and diversity we see in organic compounds. Remember, the key difference between alkanes and alkenes is the type of carbon-carbon bonds they have. Let's recap what we've learned so far. Organic chemistry, a fascinating field of study, revolves around the chemistry of carbon compounds. Carbon is the star of the show here, and for good reason. It boasts a chemical diversity that is unparalleled by any other element. This diversity is rooted in 3 key characteristics of carbon: its ability to bond reasonably well with other carbon atoms, its capacity to form strong bonds with atoms of other elements, and its knack for making a considerable number of covalent bonds. In fact, 4 of them. Interestingly, despite its pivotal role in organic chemistry, elemental carbon is not particularly abundant. It doesn't even make it to the list of the most common elements in Earth's crust. However, all living things are composed of organic compounds, highlighting the significance of carbon. Now let's talk a bit about the kinds of organic compounds we've discussed. Most organic chemicals are covalent compounds. The simplest among them are the hydrocarbons, composed solely of carbon and hydrogen atoms. Alkanes, for instance, are hydrocarbons that have only single bonds and appear as a chain of carbon atoms bonded to hydrogen atoms. The name of each alkane depends on the number of carbon atoms in its molecule. For example, methane is an alkane with 1 carbon atom, ethane has 2, and propane has 3. But not all hydrocarbons are alkanes. Some have 1 or more carbon-carbon double bonds, and these are known as alkenes. The names of alkenes also depend on the number of carbon atoms in their chain, but end with -ene. So, ethene is an alkene with 2 carbon atoms, and propane is a compound with 3 carbon atoms and 1 double bond. So next time you hear about organic chemistry, you'll know it's all about the incredible element, carbon and its compounds.